Winning a NASA contract to send scientific experiments to the moon, intuitive machines represent an exciting new future for lunar exploration. Welcome back to our channel. This is Cosmic Era. Intuitive Machines is a diversified space company focused on space exploration. Intuitive Machines supply space products and services to support sustained robotic and human exploration to the moon, Mars, and beyond. We believe our products and services offered through 4 distinct business units: Lunar Access Services, Orbital Services, Lunar Data Services, and Space Products and Infrastructure will open access to the moon for the progress of humanity. Intuitive Machines Incorporated is an American space exploration company headquartered in Houston, Texas. It was founded in 2013 by Stephen Altimus, Cam Gaffarian, and Tim Crane to provide lunar surface access, lunar orbit delivery, and communication from lunar distance. Intuitive Machines holds 3 NASA contracts under the Space Agency's Commercial Lunar Payload Services (CLPSS) initiative to deliver payloads to the lunar surface. The Intuitive Machines Nova-C, or simply Nova-C, is a class of lunar landers designed by Intuitive Machines (IM) to deliver small payloads to the surface of the moon. Intuitive Machines was one of 3 service providers awarded task orders in 2019 for delivery of NASA science payloads to the moon. The M1 lunar lander, named Odysseus, was launched by a SpaceX Falcon 9 rocket on 15 February 2024, reached lunar orbit on 21 February, and landed on the lunar surface on 22 February. This marked the inaugural Nova-C landing on the moon and the first American spacecraft to perform a soft landing on the moon in over 50 years. It is the first spacecraft to use Methalox propulsion to navigate between the Earth and the moon. Structure. The lander structure is a hexagonal cylinder with 6 landing legs and is 3.938 meters, 12.92 feet, tall. It has a launch mass of 1,908 kilograms, 4,206 pounds, and can hold a payload of 100 kilograms, 220 pounds. Nova-C was developed by Intuitive Machines, inheriting technology from NASA's Project Morpheus. Its Jumbale VR900 main engine uses methane and oxygen as liquid propellants pressurized by helium gas to produce 3,100 and 700 ULF of thrust. For attitude control, the vehicle uses a helium reaction control system. Each thruster in the RCS uses cold helium gas to produce 4.45 N 1 ULF of thrust to adjust the spacecraft's attitude. At launch, Nova-C is filled with 845 kilograms, 1,863 pounds of liquid oxygen, 422 kilograms, 930 pounds of liquid methane, and 17 kilograms, 37 pounds of gaseous helium. Propellant is loaded onto Nova-C at the launch pad alongside propellant loading of the launch vehicle. Use of liquid methane and liquid oxygen is believed to be an enabling technology for future deep space missions. Propellants aboard the lander were stored in composite overwrapped liner-less cryogenic tanks. Thermodynamic venting systems provide cryogenic cooling. Capability. Nova-C is capable of 24/7 data coverage for its client payloads. Landing. The main body of the lander is cylindrical, with 4 landing legs extending from the sides. The circumference of the main body is covered with solar cells. The bottom side is dominated by the nozzles of the main thrusters, while the top offers space for sensors and payload. The lander is designed to stay upright when landing on a slope of up to 10 degrees. The lander includes autonomous landing and hazard detection technology, and once landed is still capable of relocating itself to a second landing site by performing a vertical takeoff, cruise, and vertical landing. The system is composed of a LiDAR and a camera, which generate 2D and 3D images of the surface, and by the onboard computer, which uses these images to characterize the landscape underneath the lander during the final descent. If the area is deemed unsafe, the system orders a retargeting to a safe landing area, compatibly with the propellant left. Mission. Intuitive Machines will deliver 5 payloads for NASA to the lunar surface as part of their long-awaited M1 mission. 2 more lunar missions are also in the pipeline, all as part of NASA's Commercial Lunar Payload Delivery Services (CLPS) program, in which NASA outsources the delivery of science payloads to the moon to the private sector. The robotic M1 will head to the lunar South Pole and is a fitting destination for M1, which will be the first American-led mission to reach the surface of the moon since the crewed Apollo 17 in 1972. NASA also plans to target the South Pole with its Artemis program that will eventually ferry astronauts to the surface. Launching on a SpaceX Falcon 9 rocket no earlier than mid-February 2024, the foundation of the mission is Intuitive Machines' Nova-C lander, which is a solar-powered hexagonal cylinder with 6 landing struts, able to carry scientific payloads totaling up to 286 pounds, 130 kilograms. M1 will have 5 NASA science experiments on board. A laser retroreflector array, LRA, will allow Earth-bound astronomers to measure how fast the moon is moving away from Earth. The Navigation Doppler LiDAR for Precise Velocity and Range Sensing, NDL, will measure the Nova-C's descent to help ensure a safe landing. The Lunar Node 1, LN1, is a radio beacon that will assist in navigation. Stereo cameras for lunar plume surface studies, SCALPSS, will study, through video and still images, how the Nova-C's rocket exhaust plume affects the lunar regolith. Radio wave observation at the lunar surface and the photoelectron sheath RLSES will explore the level of space weather at the lunar surface and how it could affect spacecraft and astronauts. A second Intuitive Machines mission, M2, set to launch on a SpaceX Falcon 9 mid-2024, will head for the lunar South Pole with a new addition, the Micronova hopper, which will be able to deploy off the Nova-C lander and hop like a pogo stick as far as 5 miles, 25 kilometers across the surface. It will even be able to bounce into permanently shadowed areas where there could be ice, and then hop back out again. The Micronova is expected to take the first ever pictures from inside craters at the lunar South Pole, according to Intuitive Machines. Other experiments on the M2 mission will include an ice drill called the Polar Resources Ice Mining Experiment 1 Prime 1, to demonstrate how it will be possible to extract volatiles from the lunar surface for drinking water, air, and rocket fuel. M3 will then head to the moon in 2024. A Nova-C lander will carry 4 science instruments to explore Rainier Gamma, which is a mysterious lunar swirl associated with local magnetic fields. NASA describes how the mission will deploy a team of small robots called the Cooperative Autonomous Distributed Robotic Exploration, CADIRE, that will autonomously explore and investigate the lunar surface, as well as a small NASA rover called Lunar Vertex. Further future plans of Intuitive Machines. Beyond the 3 missions, as part of the commercial Lunar Payload Delivery Service program, Intuitive Machines have even more ambitious plans for the future. Meanwhile, the company is beginning work on their Nova-D lander, which will be larger than the Nova-C and be able to carry payloads of up to 1,650 pounds, 750 kilograms, which is sufficient for NASA's Discovery class of missions, an example of which was NASA's InSight Mars lander. However, to reach the full potential of the scientific payloads they carry, Intuitive Machines landers will need to survive for longer periods on the lunar surface than they are currently capable of. Nova-C missions can be maintained for 14 Earth days, being solar-powered. When lunar night draws in, the lander will power down and the mission will end. The Nova-C is able to keep warm to an extent thanks to a partnership with Columbia Sportswear, who have provided insulation to keep the science payloads warm, but for long-duration missions, another source of power is required. Conclusion: as we conclude that Intuitive Machines' successful landing on the moon was a result of both quick thinking by their mission controllers and a fortunate turn of events. Despite facing navigational issues and a tilted landing, the spacecraft remained intact and most of the onboard systems are functioning well. This achievement highlights the ingenuity and resilience of private space companies, further paving the way for future lunar exploration. Intuitive Machines and SpaceX's collaborative efforts have culminated in the successful completion of the M1 lunar lander fueling test campaign. This achievement holds tremendous significance for the future of space exploration, showcasing advancements in technology and fueling systems. The milestone achieved by this joint endeavor signifies the potential for further collaborations between industry-leading companies in the pursuit of space exploration and infrastructure development. The success of the mission can be attributed to quick thinking by Intuitive Machines' mission controllers and a stroke of good luck. Navigational issues arose after Odysseus conducted a planned maneuver called lunar orbital insertion. This fortuitously prompted mission controllers to activate a navigational subsystem called laser rangefinders earlier than planned. However, it was discovered that the lasers were not functioning due to a physical safety switch that was not turned off while on the ground. These lasers are crucial for determining variables like altitude and horizontal velocity during landing. Without them, Odysseus could have crashed on the lunar surface. To overcome this obstacle, the company decided to use a NASA Doppler LiDAR payload originally meant for technology demonstration. They directed Odysseus to orbit the moon for an additional 2-hour period, allowing them time to load software patches and reset the lander's guidance, navigation, and control system. This last-minute decision proved to be a remarkable save. Prasen Desai, Deputy Associate Administrator of NASA's Space Technology Mission Directorate, stated during the press conference that the successful execution on board Odysseus had elevated the Doppler LiDAR technology to the highest level of readiness to RL9. It exceeded NASA's expectations and showcased the effectiveness of the technology.